I'm Aryan, and welcome to Stay at Home Science. Today, we're going to be doing a foaming beaker. This experiment consists of a lot of different materials. I'll be walking you through them now. The first material you'll need is hydrogen peroxide. Now, hydrogen peroxide is a really common chemical. You'll see it often used to heal scrapes, bruises, and other very minor injuries. Ask your parents if you don't know where to get hydrogen peroxide. The next thing you're going to need is dish soap. Now here I have a full cup of dish soap, but what you specifically need is a pipette or something similar, full of exactly 10 milliliters. You're going to need this dish soap in this exact amount later on. The last thing you need is yeast. Yeast is extremely important to this experiment. Make sure you have a packet full of yeast, and if you don't have an exact packet, just have a tablespoon. So these are our materials. Now that we have them, we can begin the experiment. The first step is to take your hydrogen peroxide. Here we're going to be measuring out 50 milliliters. So here we go. It doesn't seem to be working. Let's just try taking the cap off, opening it up. There. It should now work. Now we just need to reattach the cap and fill it in. Just make sure to go through and fill in your hydrogen peroxide right up to 50. As you can see, it's reached exactly 50 milliliters. After that, what you're going to need is your dish soap. However, before you begin that part of the experiment, make sure you place the beaker in this pie tin. As you can see, it'll create more safety because even if it starts foaming beyond the pie tin, you can get your hands out really quickly, and the pie tin will take in some of the foam initially. So, your next step is going to have to be measuring out your dishwashing soap. If you didn't previously do this, just make sure you take a pipette or something similar and measure out exactly 10 milliliters. If you don't have 10 milliliters, or you use a different amount of hydrogen peroxide, just make sure it's about a fifth of what you put in terms of hydrogen peroxide. Now, let's fill it out. Here we have our dish soap at the very bottom. It doesn't seem like we got to exactly 10 milliliters. So let's fill it up and put in extra. Now at the very bottom of this, an extremely dangerous chemical is going to form. Make sure you do not put your fingers anywhere near the remainder of the bottom for the rest of this experiment. Next, we are going to be using the yeast. I've already opened my packet. If you didn't already, make sure you open it now. Let's take the yeast and pour it in. Alright. I don't think it'll actually be very safe. So how about, let's use a funnel. This way, the funnel will directly put in the yeast onto the experimental materials. Alright. Now, this is where the cool part of the experiment begins. As you can see, the outside of the flask is slowly getting cooler and cooler. You're going to see this happening consistently. Now the yeast is foaming. It's constantly moving out. It's really interesting how it's constantly doing this. We'll be talking about why this occurs later on. Remember to look inside. It's really interesting what's happening here with the yeast. If you mix it in, it'll get even bigger. As you can see, it's constantly growing out. This is a really interesting foaming reaction. Now, while this keeps going, let's talk a little bit about why this occurs. Now, the major thing that you see here is actually what's happening at the very bottom. As you can see, tilting it a little bit, is going to be the dish soap and the hydrogen peroxide. The thing about the dish soap is it actually causes the hydrogen peroxide to split up. Hydrogen peroxide is actually some water and oxygen stuck together in a chemical. However, once it's exposed to the dish soap, the hydrogen peroxide actually splits up. So what you're going to see at the very bottom is actually water. But what's coming out here? It's all oxygen. The air is filling up the yeast and causing this huge foaming reaction. Now, because the hydrogen peroxide is splitting up, it's actually warming up the flask a little bit. Before, this was a really cold glass flask, but now it's warm. If you're doing this experiment at home, you'll be able to tell this too. This is called an exothermic reaction. This is when a reaction becomes warmer and warmer because of what's happening with the chemicals inside. In this case, because the hydrogen peroxide is breaking apart, it's also releasing some heat energy. This is a really interesting phenomenon. If you want to learn more, make sure you Google exothermic reactions, or find out more about why yeast interacts with oxygen in this way. Thank you, and I hope you enjoyed this installment of Stay at Home Science.